Hi, we're going to be doing some more talk about Venn diagrams, solve probability problems. We're going to do an intersection problem focus this time. Just going to run through this. So Venn diagram is a space that's represented by a rectangle that has circles within them. The rectangle represents the universe and the circle represents subsets within the universe. So for example, you usually have two circles within the Venn diagram. Their intersection is where they cross. So that is the partially overlapping piece that's in the middle. Okay. So A intersection B, we're looking for the middle, and A union B, we're looking for the whole thing together. Okay. So union is or, where A or B, which is totally inclusive of both. And then intersection is and, which is I'm just interested what's in the middle. Okay. So when events are mutually exclusive, or also known as independent, you can see their circles are not going to be touching each other. That means that there's nothing in common with the sample spaces of each of the sets within the universe. So for example, if I had if I was flipping a coin, let's say the X circle is flipping a coin, so I would have heads and tails inside of here. And then the Y bubble would be rolling a dice, which would be 1, 2, 3, 4, 5, 6. Heads and tails and 1, 2, 3, 4, 5, 6 do not have anything having to do with each other, thus their circles are not going to touch. Okay, so this should look familiar from yesterday. The union of two events is denoted by A, it's like a U for union, and that's all of the elements that are in both sets. To find those probabilities, you need to find the total number of students in the school for this problem in particular, which includes the number that is outside of the two circles. So for example, this 475 tells me that there's 475 students that are not band members and not club members. Okay. So if I wanted to find the total number of students, I need to add up all the numbers within the universe. And then that would be my new denominator to figure out probabilities. Okay. And now intersections, we're just looking for the things that are in common. So for example, this 12 is in the intersection, and that would tell me a keyword would be both. So if this was soda drinkers or coffee drinkers, and soda drinkers, the 12 would tell me that there's 12 individuals working in the office that drink both. Where we would have 31 people in the office that solely drink coffee. We would have 25 people in the office that only drink soda. So just be aware of how we can be interpreting these pieces. Now, complements is all the subsets that are not in an event. So for example, if I wanted to know how many people do not play volleyball, where A is playing volleyball, it would be included of all the information outside of A and all the information in B. Including this middle, because if you're in the middle, that means you're in both. So just because this person plays softball and volleyball doesn't mean that they quote unquote don't play volleyball. Okay. Now we're going to go into the multiplication rule. This is that intersection. For independent events, all you're simply doing is multiplying the probability of A and the probability of B together, and then that will give you your middle section. And then if you have dependent events, that means that they are overlapping in the Venn diagram. Their probability is the probability of event A times the probability of event B, given that A has already happened. So this is just saying if you have situations that don't have replacement or things of that nature, you would be using this second equation. So the product of the probabilities is used for independent events, mutually exclusive events. And then for dependent events, we are using that product of event A and event B, given that A has already occurred, which is this notation with this straight line. Okay, so let's go into an example. If I have an urn that has 6 red marbles and 4 black marbles, 2 marbles are drawn without replacement from the urn. So that means I'm not putting them back in. So I would be using this dependent equation. So let's go back to that. So the solution is A would be the event that the first marble is black, and B is the event that the second marble is black. So we know that there are 10 marbles in the urn, okay? 4 of which are black, so the probability of picking a black one first would be 4 out of 10. And then the second one, there will be 9 marbles in the urn because I'm not replacing it. Okay, and 3 of which are black now because I took one of the black marbles out. Okay, and therefore P of B given A is 3/9. So if I wanted to find the probability of both marbles are black, I would multiply these two together. I would get 12 over 90. We get 12 over 90, which is about 13.3%. Okay. Now visually it's really easy. So like you're just looking for how many events are in common. So but you just have to remember that I need to put these numbers into probabilities. So I have 12 out of how many total things do I have? I have 25 plus 12 is 37. 37 plus 31 is 68. And then 68 plus 83 is 151. So the probability of this middle here is 12 out of my total 151, which is about 7.9 percent. 7.9%. So here you just have to remember you have to make the probabilities. Okay, so for example, you'd have 31 over 151, which would be just A, not including the middle. 12 over 151, which would be both A and B. 25 over 151, which is just B. And then 83 over 151, which is not A or B. Okay, when you don't have a visual, you can use that multiplication rule to determine those solutions. So here's an example with no Venn diagram. I have a survey of couples in a city, found these following probabilities. I have a probability the husband is employed as 0.85, probability wife is employed is 0.6, and the probability that both parents are employed or both partners are employed are 0.55. The couple is selected at random, so find a probability at 1, at least one of them is employed, and 2 is neither is employed. So where both are employed, or at least one are employed, we would have P of A union B. So this is a union problem. We have P of A plus P of B minus P of A union B. A is husband, B is wife. A union or intersection B is both. So I would just plug all of this into my equation, and I would interpret this. 90% of couples have a one employed partner. Now, neither is a complement of this problem. So if someone is employed, at least one person is employed, the complement of that is no one is employed. So we take 100%, which is work or not work, minus 90%, which is both work, which we found in the last problem. And then you get 10%, which neither is work. Now here, this problem is very easy because I have 0.55. 0.55 is the probability of both. So that is my intersection already out there in plain sight. Some of these problems you just really have to take a second and think about it, have a conversation with yourself. Just say, self, what is it that this problem is actually asking me to do? Okay, but that's it for me. Please feel free to comment. Please feel free to reach out to me with any questions, comments, concerns, issues. Looking forward to your continued work. Have a great day.